I'm really glad to be presenting today about probably the two least sexy conference topics ever, legacy code and testing. When I was in Cégep, I took part in some career day experiment and followed a software developer for a day. And that's a guy who was working for the government of Quebec. And his only job was to make sure that on January 1st, 2000, welfare checks would be printing properly. And you can probably imagine what it looks like if welfare checks stopped being printed. And he was working in an old, probably 30-year-old COBOL system. And to me, that was pretty much the definition of hell. And it's a miracle that I still chose to major in computer engineering after that. But I swore to myself, I'm not going to be doing a job like that one. And I decided to go for the most high-tech, innovative field I could find. So I did my master's in computer vision. And then I worked for about a decade in computer-assisted surgery, doing knee surgeries with high-tech sensors. I then moved on to Unity, where I worked in the animation team. And I now do work with VR and how we can use VR for mental health. So that part of the plan worked out pretty fine. The part where I completely failed is avoiding legacy code. Because the fact is that legacy has very little to do with age, and it has a lot to do with what the code actually is. Legacy code, I like to define it as code that is undocumented, untested, and untrusted, so that anytime you change something, everything breaks. And that's the state in which every line of code is doomed to go eventually. But some forms of code decays a lot faster. And if you work in a very innovative field, your code decays really, really fast. Often it's because you've been working on a quick proof of concept, and somebody says, oh, cool, let's ship it. And it wasn't planned for that. Or you acquire a startup, and you get a whole bunch of code that to them was not legacy, but to you immediately becomes legacy. So the more you work in innovative fields, the more you need to know how to work with legacy code. And legacy code is not something that you need to throw away. There's a way to turn that around and work with it, but you need to be willing to. So what I wanted to propose today is one recipe for dealing with legacy code. It's not the absolute recipe. I don't believe in absolute recipes. But it's one I cobbled together from my experience, both at Zimmer and Unity, and now at the NRC, and also from mentors I've met and read along the way. So I hope you can take some of that recipe in yours and get a little bit better at working with legacy code. So let's assume you've just inherited a large, unstable code base, and that's now your mess, and you have to deal with it. The official answer from TDD experts would be that you need to stop everything, test everything from the ground up, and then you can start debugging, refactoring, and deploying new features. Who has seen this work in real life, like stopping everything for a year and just writing test code? How well did that work out for you? Did the project get canceled? That's usually the fate of those projects. And it makes sense, because if you have a product that is in production, you still have customers behind it who need new features and who need bug fixes and who need maintenance. And these are the people paying your salary. They don't care about your test code. They don't care about your debt. That's your problem, not theirs. And you still need to support them. So you need to find a way to work with legacy code that lets you still do what is your core job, and yet pay back that debt. And my strategy is very simple. You want to test what has failed, and you want to test what's going to fail. So that should cover everything up, right? The first part is the easiest to start with. Just take any bug, the last bug you've fixed, and write the tiniest bit of test code that covers it. And you don't need anybody's permission to do that. That's your job as a software developer to test what you've just fixed. And at this point, you don't want to get fancy with testing. You don't want to fall down the rabbit hole of trying to find the best test framework. Anything will do. I mean, a cout will do. And a cron job on your development machine can be your continuous integration system. If you have nothing, that's better than nothing. And if you get the discipline of doing this, every time you fix a bug, you write the test case for it, you're going to start building the seeds of a test infrastructure. And one nice thing about bugs is that, like real bugs, if you find one in your kitchen, chances are there's a lot more nearby. So you're going to start fixing not only your own bugs, but you're going to start finding other bugs. But even better than that, you're going to start finding regressions. And customers are, strangely enough, fairly tolerant of bugs and new features. They probably shouldn't be, but they've grown, they've learned that when a new feature gets rolled up, usually it's crappy, and that's the way life is. But if they've been relying on something for several years, and you break that thing on which their production depends, they're going to be very, very, very pissed off. So if you're able to catch regressions, especially regressions from your colleagues, before they hit the customer, people are going to start to see value in that weird testing experiment you've been doing on your own development machine, on your little corner. And that's when you're going to start getting noticed, and you're going to start getting a little bit more budget for testing, maybe. And don't expect a single light bulb moment where everybody sees the light of testing and starts doing perfect unit tests for everything they do right now. This is a hard-won battle, and it's one that you're probably going to win one developer by developer. People have to feel the pain for themselves and see how that code base, that testing base has saved their ass before they can believe in it. So you're going to have to win that one person by person. And you will never get enough budget to test the way you would like to test. That's reality. You could get half of the development budget for testing, and if you're a perfectionist, it's never going to be enough. You're never going to feel 100% safe, but that's just what we're dealing with. But once you reach that tipping point, you might be able to start testing what's going to fail. And I know it looks stupid, I don't know what's going to fail. If I knew, I wouldn't have bugs. But honestly, we all know where the ugly code is, right? We know which are the modules that are keeping us awake at night, or the bits of algorithm that no one wants to touch because no one understands what's there. That's what you want to test first, because that's where the bugs are lurking. It's like, I'm not going to open that drawer because I know it's full of cockroaches. That's what you want to open. And that brings me to a couple of pitfalls with testing. The first is we have to be very, very careful about code coverage tools. I love code coverage tools. I think they're very useful to see where are your blind spots. But in most cases with legacy code, you don't have blind spots. You're just blind everywhere. You don't need a tool to tell you what's not tested. It's straight in front of you. And the problem with code coverage tools is when you start looking at the code coverage metric itself. Because human beings, being what they are, we really like to see that number go up, especially if we're rewarded for it. And that means that you're going to start testing getters and setters and things that are guaranteed not to fail. And no one will want to test that ugly algorithm that the minute you start testing it, everything is going to break, you're going to find bugs. you're going to have to fix those bugs. And your code coverage number is not going to increase because it's probably just a few lines, but they're so crappy that it takes forever to test. So you don't want to look at that metric and start rewarding people for being lazy and start punishing people for attacking the hard problems. The other pitfall is what I call canary testing. You know, in old mines, people used to bring canaries in a little cage, and the canaries are fragile little birds that sing all the time. So when the canaries stopped singing, you knew it was time to get the hell out of there really quickly because there were probably toxic fumes or something. And we can do the same thing with testing. If you have a big, complex algorithm that nobody really understands, you just feed it a bunch of data, look at the output, and you make that your new standard. You trace a line in the sand, and you say, from now on, if anything in there changes, I want to know about it. And when it changes, the test is going to fail, so we know about it. And it's a really good way to get really quickly some good coverage when you have nothing. But the problem is that this test is going to cry wolf all the time. Whenever you fix something, whenever you change an underlying library, the output is going to change ever slightly, and it's going to fail, and people are going to stop trusting that test. And a test suite that is halfway read all the time and that everybody ignores is almost worse than no test suite at all. So if you have tests like that, try to refactor them as soon as possible into something a little bit more robust. And sometimes you have no choice. Like if you're doing graphics code, you're probably going to have a pixel-by-pixel comparison at some point in your test suite. And in those cases, you want to make it very easy for lazy programmers to update the test when it breaks. Because you want your test suite to be green all the time. And that leaving a test red is like a capital offense. The final and third pitfall is the idea that with good enough automated testing, you can get away with manual testers. I've never seen that work in real life. Some companies have done away with manual testers, Facebook, for instance, but actually they just call them users. And very few of us have enough of a market share to be able to alienate our users by just sending them crappy stuff and letting them find the bugs. And if you're working in a high reliability environment, if, for instance, your software is used to operate human beings, you kind of want to test them. And the important thing is that manual testers are not a replacement for computers. You want to make sure that the human beings in your QA process are being used as human beings, which means that you're tapping into their creativity and most of all into their deviousness. We're very good at breaking things as humans and finding the flaws. So you want to make sure your testers are using that. And there's a bunch of techniques to use and hone in on that creativity. I really like the exploratory testing approach. I have it in the refs at the end, which is ways of finding new angles to break software. And there's lots of things you can do with manual testing that is smart and that doesn't try to replicate what a computer can do. But in order to do that, there's a very important concept. You need to treat your testers like valuable members of your development team. Manual testing is not an entry-level job. You need somebody who understands the problem domain really, really well, and you need somebody who is smart, sometimes even smarter than your development team, because this is really hard. And these are the people who are going to be your user experts. They're going to be often part of the UX team. They're going to understand your software better than anybody else. And you want to pay those people and reward those people and respect those people. And deep down, ultimately, working with legacy code and being able to create quality products that span several generations of developers is not so much about tools. It's a lot about culture. And you need to build a culture of respect and diversity around your team. It's respect for your day-to-day colleagues, just cleaning up after yourself and taking responsibility for your errors, like what my kids are learning in kindergarten right now. It's about respecting the people who are going to come after you and just leaving traces in your comments about the difficult decisions you're making, or the struggles, or the reasons why you're taking that hack. And it's a lot about respecting the people who came before you. We're all guilty of the same knee-jerk reaction of looking at code and saying, like, who's the idiot who wrote this? But the truth is, very few of us in this industry are complete idiots. I mean, most software developers I know are very smart people. We just do the best that we can with the knowledge that we have and the tools that we have. And sometimes that bit of ugly code is the hack that allowed the company to release before it got bankrupt, and the very reason you have a job today. And sometimes code is messy because the reality it models is messy. Like real life seldom fits in nice, elegant solutions. And if you just throw away that code because it's crap, you're losing on all that subtle understanding of your problem domain. And sometimes that person didn't know better. And that's still not a reason to go name calling. You wouldn't, throw insults at a junior developer. So why do it at somebody who came before you? And especially if that person is you 5 years ago. So in most industries, a legacy is a good thing to leave behind. Like we talk about John Coltrane's jazz legacy, and it's a good thing. So why has it been turned into a slur of words in our industry? Think of it this way. The code you're writing right now is worthless until it starts being used. And the code that you've invested in and that your customers are using is the code that is reaping you dividends right now. So if you just throw away everything over and over again, you're throwing away your investment. You're burning down your house and building a new one every month. And because of that, you're not innovating. If you want to be able to do R&D and to do exciting new stuff, you need to be setting on a solid foundation of code that you trust. And that foundation is your legacy code. So let's try to learn about legacy code. I know it's hard. It's more fun and easier to write new code than reading old code. But that's what we're supposed to do. We're engineers. We're supposed to tackle hard stuff. So let's be courageous and tackle the hard stuff. And let's think, instead of working and leaving behind legacy code, let's try to leave a legacy of good code. Thank you.